Okay, so we started talking about call by value, call by reference, and simulated call by reference yesterday. We said that we already knew call by value and simulated call by reference from our C course. Now we are talking about call by reference, and I think I gave you our first. Stop talking, okay? Are you done? Okay. So this is our first example of the call by reference mechanism of passing our arguments to the functions. We have these three functions as examples. Remember, get number. It will take two numbers from the keyboard, and it will modify whatever we send. And then we have swap values, and we have the show results. As you see, these both functions, get numbers and swap values, they receive their parameters by reference, but show results, it receives its parameters by call by value. And this is how I call them. Let me take this out. We talked about this yesterday. Okay, so I simply have two integers declared. Then I send this to get numbers. Get numbers will read two integers from the keyboard and will modify first num and second num. Okay, that's call by reference. Then we are going to swap their values, and then we will show the results of first num and second num. That is, we are going to print them on the screen, the first num and the second num, and we are going to see that the numbers are the integers are swapped. Okay, so that was a simple example, and this is how we do it. I mean, you use these two integers as like regular integers, and you don't care if they are references or not references. It is not like using a simulated call by reference, okay? Because with the simulated call by reference, you had to use the dereferencing operator. In this case, you don't use any dereferencing. You just use those integers, and that's it. And when you are done, of course, you return this function. The second one is similar. Like I am doing regular programming, I am writing my program with variable 1 and variable 2 as like regular integers. And whatever I modify, okay, whenever I modify variable 1, variable 2, okay, these two values are modified, right? These two integers are modified. That's the meaning of call by reference. Okay, that's the meaning of call by reference. This one is not call by reference. This one is call by value. So output 1 is actually a copy of first num. Okay, in this case, output 1 is a copy of first num. But in this case, get numbers input 1 is the same as first num. Okay, they use the same memory location. They are just two names referring to the same memory location, first num and input 1. Later, when we do the swap values, in this case, first num and variable 1, they become the same name to the same memory location. But when we make this call line 15, okay, in line 15, when we say first num, send first num here, okay, this function will make a copy of first num. So output 1 is a copy of first num. So whatever, if you change output 1, first num will not change. Okay. So call by value is actually more expensive, right? Because it makes a copy of it, right? It makes a copy. Call by reference doesn't make a copy because I use the same memory location. I don't have to make a copy. Maybe for integers and doubles and for characters, it doesn't make much of a difference in terms of copying cost of integers and doubles and etc. But if we are sending something very large, let's say I'm sending a vector, right? Remember the vectors? Vector is something large. Or I am sending a string. Okay, they are very large. So making a copy of that string is costly, or making a copy of that vector is costly. In that case, even though it is not your intention to modify anything in your function, sometimes you may prefer to use call by reference because of the performance concerns. Okay, you say that okay, call by value is fine with me. I like to use call by value, but call by value is going to be expensive for this parameter. So why don't I use call by reference so that I don't get hit by the copying cost of this parameter. Okay, so we are going to talk about this later. And in fact, we use call by references most of the time for this purpose to prevent any copying of unnecessary copying of large data. Good. Any questions about call by reference? Okay, I think we talked about these stuff yesterday, and this is how we used to do things in C. I mean, I could have done the same thing in C, but I had to use simulated call by reference through pointers, and this is how you call your functions. C people, they like this kind of annotation. When you say it, when you say get numbers, address of first name, and etc., this looks much better than this version. Why? Because as soon as I read this line, I know that there is a possibility that somebody is going to change first name because I am sending the address of it. When you read this one, line 13 by itself, I don't get that feeling. I need to go back and I need to see the definition of get numbers. Well, in the get numbers, there are references. So in that case, I can say that there is a possibility that first name and second name is going to be changed or might be changed. Okay. Did everybody do the attendance thing?
I couldn't because of internet connection.
Okay, you are going to sign your name on the paper. Okay. How many people didn't sign it? One. Okay. Let's move on. Let's move on. And call by reference details. Call by reference details. Actually, what is going on with the call by reference is same as what we do with the C programming language. The compiler sends the pointer for us, okay? And the same thing as the sending the pointer and doing the referencing thing, it kind of same thing happens. So the performance-wise, they are the same thing, call by reference and call by simulated call by reference. Performance-wise, they are the same thing, but the way that we use them is, of course, they are different. Okay, there is a well, when I'm writing this program, I need to be careful because I had to use the pointers, right pointers. I had to use the referencing pointer all the time, and I have to remember that I am doing the simulated call by reference all the time. But with the implementation of this, I don't care about any of those. I write my program as a regular. I mean, if I don't see these lines, line 24 and 32, okay, line 24 and 32, if I don't see those lines, then the rest of these functions are almost the same. They look the same, right? I mean, I write them the same way. Okay, I write them the same way. With the simulated call by reference, the look of the functions are very different. So they are more convenient to write it. That's what I'm trying to say. Okay, let's talk about this. Okay, the copying thing. Okay, I have a function like this. It takes two integer references as parameters. Okay, so this send constref function, it can modify the values of these parameters, but I put these const modifiers at the beginning of the parameter definition. Okay, I put the const modifiers at the beginning of the parameter definition. So what does that mean? It means that although I am receiving these parameters as a reference, integer references, I promise to the outside world that I am not going to change them. Okay, so that doesn't sound very meaningful. I mean, I am sending it as a reference, but I am saying that I am not going to modify it. So why are you using the reference way? Why don't you use a regular call by value? The answer is, of course, to get away from the copying cost. Okay, this one will not copy the integer. Okay, this parameter one will be the same as the whatever you are sending. That's one thing. Okay, it will not copy, but it will not change it either. So if this is what you want, okay, you want to do the call by value, but you don't want to get hit by the copying cost of these parameters, then you do this. Okay, and in fact, that's the rule for the C++ programmers. Okay, always, okay, always use const references when you write new functions. Okay, other than the fundamental types, except the fundamental types. What is fundamental type? Fundamental type is the types that I showed you last week, integers, doubles, floats, and etc. Because, I mean, if I am not going to copy this integer, then I will have to copy the pointer of this integer. I mean, copying a pointer and copying an integer, it is the same cost. So for the integers, this is not any faster than doing the call by value. But for other types, such as strings and vectors and your own classes, okay, doing this is definitely faster than using call by value. Okay, so that's why we say that we are going to use call by reference a lot for the class type parameters. I think we have seen just two of them right now. Okay, strings and the vectors. You use it this way. Okay, always send them using call by reference and put a const in front of it. If you modify these two values in your function, then compiler will give you an error message say that, okay, you cannot modify it. So this is something that we use all the time. Here is an example. Okay. So I am saying that I am getting this integer vector v by reference, but I promise that I will not modify that v. All I am going to do is just access the elements of that v, nothing else. Okay. So this printVec makes this promise. This is constant. So calling this printVec is fast. Why? Because it is not copying this whole vector. If this vector is of size 1000, can you turn off that computer? Yeah. Because I didn't make any jokes, right? Did I say something funny? If I say it, I'd like to say it again. No? Okay. So if I send this vector, which is a large vector like 2000 bytes long or 2 kilobytes and etc., I don't want to copy it, so I send it as a reference and put a const in front of it. That will make it fast. But the thing is that if I am calling this function f, okay, inside this printVec, f cannot modify this v either, right? Because, I mean, if f modifies v, then I am breaking my promise to the outside world. That's a bad thing. So that's why the definition of f should take a constant reference v. Otherwise, compiler will give you an error message here. Says that f doesn't take a constant reference v, so there is a possibility that f can modify it. So I am going to give you an error message. Okay, so if a function receives a constant reference, then it should be careful about it. It shouldn't modify it, or it cannot call another function that can modify your constant reference. Good. Any questions here? Okay, let's do the attendance thing. By the way, for those of you who are coming late for the first lecture, I told them, you cannot. Where is it? Yeah. You cannot sign the attendance sheet. I am going to take another attendance in the second lecture, okay? So there will be 2 attendances every day for the first lecture and the second lecture, so that if anybody attended the second one, not the first one, they can get the credit. Okay, oh, this is not that. I have to go from here to there. I have to log in. Sorry to. Now, do it. So, how many people? Oh, this is adding all the numbers, 202, okay. Good. So I am going to look at today's date only. So we will keep adding all those names. Maybe Ilhan can clear this up every day. I will ask him. Okay, so is Emre Yavuz here? Hasan Karakuş? Buse Deniz? İlkay Boğalat? Tarık Çelik? Diyar Si? Emre Oytun? Selim Aynigül? Okay. The first. Okay, Abdullah Revaha. Okay, thank you. Good. Let's go back to our slides. Parameters and arguments, I think we talked about it, okay? We said that these are, this is just a convention. Well, I may not obey this rule, but I mean, this is the rule. These are our parameters, okay? These are our formal parameters for this function. Whenever you are writing the function, whatever you are receiving is a parameter, but these are arguments. Arguments are the data that you send to the functions, okay? But first num and second num, my arguments to get numbers, but input 1 and input 2 are parameters. Parameters are different from arguments, okay? And the names are different. This program nicely chooses correct names for the parameters and arguments. For the get numbers, these are really inputs, right? These are really inputs because I am going to get them from the keyboard. They are my inputs. For the swap values, okay, these are my variables. I am going to swap the values of these variables, okay? And show results, these are properly named outputs. But for this one, these are just 2 integers for me, okay? Integer A and integer B, first num and second num, okay? So These are the argument names, nicely done, but for the parameter names are like that. Okay, so we talked about this, the distinction between the name, argument, and the parameter. Okay, we already did that before, and that's why I'm going to skip it. When you are doing call by reference or call by value, you don't have to, for a given function, you don't have to do the same thing for all the parameters. Let's look at this function. It says I'm going to take 3 integers or 2 integers and a double. The first integer is going to be a call by reference. Second one is going to be a call by value. And the third one is going to be a double reference. It's a mixed call, okay? And you are free to do this kind of function definitions. And in fact, most of our functions will look like this. Okay? Good. So there is nothing surprising here. By the way, this type is very different from this type. I mean, integer reference doesn't mean it's an integer. We like to think it that way, but it is not, okay? It is like integer pointer is different from an integer, right? But using the dereferencing operator, I can get an integer out of an integer pointer. The same distinction kind of applies there too. Why am I telling you this? It is because, I mean, wherever you use an integer, you cannot use an integer reference, right? So I can call this function, okay? I can call that function with this line a, comma 7, comma d. This is an integer, this is an integer, and this is an integer. But this is a variable, a constant. This is fine, but this is not fine. Why? This line is a bad line, the first line. It's a bad line. The second one is good, the first one is bad. Who is talking? What did you say?
First argument is constant.
Yeah. Well, I mean, if you send a constant to a function that needs an integer reference, you cannot keep a reference to a constant. Like, you cannot take the address of a constant, right? So what are you going to do? I am going to give you a compiler. This will not happen. Okay. So I can. That's what I am saying. Integer references and integers are not exactly the same thing. Most of the time we like to think it that way, but you should know the distinction. If they are the same thing, then the first line would have been okay, but it is not. Yes?
Where do we keep constants in memory?
I think somebody asked this question. Did you ask it like last week? Last week somebody asked. Well, I mean, remember our, let's say, this is our assembly instruction move, right? Sometimes we say that move a value to register R1 from this memory location 2752, right? This is a hypothetical assembly language. But in this case, I am trying to get a value from memory location to register R1. This is like a variable. But if this is like assigning one variable to another one, etc., you can do that. But if you are doing this, okay, move R1 directly to 27, okay, that's a constant thing. So when you are using constant, when you are using your constants, okay, when you look at the produced assembly code, you will see instructions like these, okay? Your constants will be directly in the assembly code, okay? So there is no, most of the time, there is no constant memory location most of the time, okay? Well, I mean, the situation is a little bit different than this because constants are, for many assembly languages, constants are defined at the beginning of the program. These are my constants, etc. But that doesn't give them any memory location. But at the end, it's going to look like this. So it will be buried inside the code itself. Good. Any other questions? So that means it is efficient, right? I mean, keeping constants in the code, it is efficient. You don't have to load it. It is directly in there. I mean, when you load your program to the memory, the constants are already where they need to be. You don't move them around. But for some reason, we don't like to use constants a lot in our programming languages because we call them magic numbers, right? Magic numbers. And we don't like magic numbers, okay? We don't like statements like for I from 0 to I less than 72 plus I. We don't like this kind of code because what is the meaning of 72? When I read it, I don't understand it, okay? What is 72? It turns out that 72 is the number of people in my class and etc. If you are going to use 72, maybe you should, at the beginning of your program, okay, constant integer number of students and the value is 72. Then instead of 72, use this ns here, right? So that way it is more readable, or when you need to change this number, just change this number, and whenever this ns is used, then I know that the compiler is going to change those too. Okay, so the compiler does this, putting the 72 in the appropriate assembly instructions for you. Of course, in the assembly world, things are very different. Assembly is for the machine. C, C++, Java is for us. So take advantage of this kind of a structure. When you say something is constant, so the compiler can think, okay, if this is constant, then I can optimize it, right? I can put these values directly in my assembly routines, right? If you don't put a constant in front here, okay, compiler might think that somebody is going to change ns later, okay? So I cannot optimize this code. I cannot put this 72 in my assembly instructions. I need to put this 72 in a memory location, and I need always use this kind of a assembly instruction. Go to memory, get that value, put it in R1. Even though I am not modifying ns anywhere in the program, I am kind of not giving enough information to the compiler. But if I put a constant in front of it, compiler knows it. Java people, Python people, or any people other than the C++ people, they don't talk about stuff like this because they don't care about the assembly. They don't care about what the CPU is doing. They say that, well, my machine is powerful enough. I don't have time for this kind of detail, okay? It is difficult to learn. It is difficult to master, and I don't need it. So I am going to do whatever I feel is right. So their program works too, but remember the table I showed you the first day? Python program spends, like, it consumes 72 times more energy than a C program, you remember? So that's the hit, right? That's the penalty. If you don't care about that, then Python is fine. Java is fine. On the average, we are wasting, like, what did I hear? Yeah, on the average, the American people are wasting 172 kilograms of food every year per person. It's like 1/5 of a ton, right? They are. So life is like that. I mean, if we are wasting food like that, why don't we waste CPU time? Well, I mean, that's a way of looking at things, right? We can do that too. Okay. This morning I heard from the news that we are spending 500 minutes per month on the phone by just talking, right? I think we are the first in Europe with this number. I'm not sure about, but I mean, the thing is that we are first in the Europe with this number. So that means we have time, right? Choosing the formal parameter names, okay, it should be, of course, meaningful. And it should be, if you choose your parameter names, go back to this function, your parameters names and your argument names are the same, then you are doing a mistake. You are doing a mistake. You are not thinking your program right. Okay, so they should be different. Their meanings are different. This is something to send. This is something to, whenever I receive such things, I am going to do this and this. Okay, using first num and second num for this get numbers is not a good thing. First num and second num is not a good thing. Of course, it will work, but it is not readable. This is what that slide says. Okay, to use the correct names. Okay, any questions so far? So I'm going to start talking about this important concept of overloading. We talked about overloading a little bit before, and we have been using overloading too, right? Because when we say 1 plus 2, okay, plus is an operator that does the integer addition. Here I am adding two floating point numbers, okay, two doubles. The meaning of this plus and the meaning of this plus is very different, right? The function that runs for this plus is different than function that runs for this plus. So we overloaded the meaning of this plus before, and see, we have been doing this. So now, why don't we apply the same idea to the functions that what C++ says? We can have the same name, okay, for two different functions. Those functions are doing similar stuff like the addition, but they are different functions. That's called overloading, okay? So overloading means that using the same function name to write two different functions. For that, I am going to make this definition of signature, okay? Signature of a function is this. I don't want to erase this stuff. These are nice, but let me hide them for now. Input show, yeah, don't show it here. Okay, good. Then I'm going to show it in a few minutes. Okay, so the overloading is this. Same function name. I have two functions. Their names are both same. Let's say add. Okay, same function name, but their parameter lists are different. Okay, in C this is not possible. In C++ it is possible. Let me show you an example, and we will come back to this. Okay, I have two average functions. One takes two doubles called by value. The other one takes three doubles called by value. If you try to compile this program that contains these two average functions in the same program, okay, C compiler will give an error message. C++ says it is okay. The name average, the function name average, is overloaded. I am giving more than one meaning to this average, okay? It is possible in C++, but not possible in C. That's called overloading. That's the same thing that they gave to the plus operator. Plus operator has more than one meaning. One is adding two integers. The other one is adding two floats. Later, we give in C++, we gave another meaning to it. We can add two strings too, right? ABC plus DEF, remember? So we overloaded even more. So you can, if you have a new type, you can overload a plus operator even more too. It's the same thing. So same function name, but different parameter list. Compiler is smart enough to see which version of this function is being called. For example, when you say this, AVG gets the value of average 5.2, 6.7. It knows that it's going to call the two parameter version of this average, and this, in this case, it knows that it's going to call the three parameter version of it. Okay, so this is called overloading. So what is the big deal about it? Well, there is nothing big deal. There is nothing complicated about it. As I said before, everything what I'm going to tell you in this class of object-oriented programming, they will be all simple things, but they add up together. That's what makes it complicated. So let's go back to the definition of this overloading. As I said before, there is a concept named signature of a function. Okay, in C++, a function signature is its name plus the parameter list. Okay, so average, remember the average function, average and the parameter list is the signature of a function. And C++ says that each function should have a unique signature. Okay, since this one, average plus 2 doubles, is different than average plus 3 doubles. Okay, each one has a unique signature. They are different from each other, right? One has 2 doubles as parameter, the other one has 3 doubles as parameter. Their signatures are different. Since each one has a unique signature, then they can coexist in the same program, no problems. Their signatures are different. Okay. In C language, we have the signatures too, but the way C defines the signature is different. C says that the signature of a function is its name. Right? That's it. That's it. The signature of a function is its name, and it has to be unique. If the signature of a function is name, then it has to be unique. Then, according to C, these two functions, they cannot co-live in the same program because their signatures are exactly the same. Okay? So, coming from the C world, if you know the definition of signature, then you know that it is very difficult impossible to overload a function, because when you try to overload a function with the same name, their signatures will be the same, and that's not going to be good. Okay, so in the C signature, I just have name. In C++ signature, I have name and the parameter list. In C signature, okay, in C language, these two functions, they cannot coexist together. It is bad. But in C++, all these green stuff are okay. A function with a double S string, a function with a single parameter double, a function with a single parameter string, these are all returning integers. But I put a red mark in here, which is correct. A function that takes a double, same as this one, well, maybe if I change the return type, I can overload it. The answer is no. Because why? Signature does not include the return type. Okay? Signature says that, okay? What defines the signature is its name plus the parameters. The number of parameters, order of parameters, and the types of the parameters. These three functions, okay, they have the same name, but their parameters are different. In the first case, the number of parameters is different. Between these two, number of parameters are the same, but their types are different. Okay? In this case, these are exactly the same signature because their names and the parameters are exactly the same. Although the return types are different, okay? Signature, the definition of signature does not include the return types. Okay? Yeah.
In C language, there is no operator overloading. Yes?
Yeah, in standard C, no, there is no operator overloading.
But we can use add function. How can we use it?
Well, that's a very good question. If there is no operator overloading in C, how can we use the add operator for the doubles and integers? Well, when I say operator overloading, as a user, as a programmer, I cannot overload the operators. Okay? When they designed the language, they designed the plus operator in an overloaded way. Okay? They overloaded and they said, okay, these are your operators, and some of them are overloaded, you use it. But as a programmer, as a user of that language, I cannot overload them more. I cannot add more meanings to the same operators or same functions. In C++, it is different. I can give new meanings to plus operator. Yeah. Why? Why do people use the overloading? Well, isn't that nice to write these kind of functions? Where are those? Well, yeah. I mean, in C, if you are going to write this function in C, you have to say average 2 and average 3, right? No, I don't have to say it. I just say average. And I don't care if it is 2 and 3. In C, there is a function arctangent, right? And there is another function, it is called arctangent 2. Arctangent 2 takes 2 parameters, 2 doubles. It is for, remember, I mean, for some of the arctangent inputs needs to be infinite numbers. That's why just a single arctangent function with a single double is not enough. You need to write another one. So there is another one. This is called arctangent 2. So why don't I just overload this arctangent? I don't care if it takes a single parameter or 2 parameters. So that would be useful. And when we start discussing our classes, and we will see that overloading is very, very useful. It hides lots of class usage details from us. Okay, we just simply ignore those kind of details because of overloading. It will be very, very useful. So that's the right way of thinking. Why are you talking about this simple stuff for the last 15 minutes and I don't see any purpose of it? Well, I mean, if you say it, that means that either you didn't understand or you missed a point. So I ask that question and I will try to answer it. Yeah.
Does order of the parameters matter?
Sure, yeah. I mean, this one, integer f, integer string, is different than integer f, string integer. Okay, these are two different functions. Their signatures are different. Okay, what is signature? The name, the parameters. Parameters means number of parameters, types of parameters, orders of parameters, etc. By the way, what did I say? Integer references are different from integers. This is a function that takes an integer. This is a function that takes an integer reference, and these two are different. Integer references are different from integers. How does the compiler resolve it? Okay, it resolves it. It has its own way of doing stuff. Sometimes it gets confused and it gives me an error message, etc. But most of the time it is fine. By the way, write all these functions and produce the assembly code and see what kind of names gives your assembly code to this function f. I mean, your functions will be assembly functions. Each assembly function should have a name, okay? And their signatures has to be, of course, different. And there is no overloading in assembly. And the compiler, in a smart way, chooses a name, a different name for each of these f's. Inside the name, you will see these types, okay? So name of the assembly function will include the type. And you will see that there will be two different functions, f, one for the call by value integer, the other one is the call by reference integer. Okay. Move on. We talked about this average. Okay, compiler resolves the invocation based on the signature of function call. And as I said before, sometimes compiler cannot resolve it. Compiler say that I don't know which one to call, this one or that one. Okay. Let's talk about that one. When the compiler sees a function call, it tries to find the function, which function is being called. It tries to find it. And to do that, it follows these two steps. Can I find the exact signature of the function? Okay, when I call this function f with an integer, is there a function definition that takes a single integer? Okay, That's called the exact signature. If it is, then it calls it. Otherwise, it looks for a compatible signature. I didn't call this with integer, but let's say I called it with a character. Okay? And all of my f functions are this. One takes integer, the other one takes string, the other one takes double. The compiler say that I didn't find a function that takes a character. Can I find something compatible? Can I convert this character C into one of these? Okay. And it is possible to convert C very easily to integer. In fact, in C programming language, we treat the characters like that, integers, right? So it makes a C out of, it makes an integer out of the C, and it calls the second one. So that's the compatible signature. Okay, compatible signature. Exact match, if it doesn't happen, compatible match. What is compatible match? It tries to do the promotion. I can promote character to an integer. I can promote character to a short integer, and etc. I can promote an integer to a double, do the promotion. If the promotion doesn't work, how about demotion? Can I convert this double to an integer even though I am going to lose some data? Yes, I can. Are there any integers being fed as a parameter to a function? If there is, then it will do this. Okay? But our suggestion is always plan for the exact match. Okay? Always plan for the exact match. In this case, I have two f's. One takes a double, or the other one takes a string. When I call this function f1, there is no exact match, but I can promote this one to become a double. So temporary double 1.0. I did it, and I feed that temporary double to this function f, and I call this function. That's called overloading resolution. Of course, this is done in compile time, right? Your produced assembly code doesn't know what overloading is. In the assembly code, function names are unique, okay? There is no overloading, and this kind of overloading resolution doesn't happen during the runtime. Runtime is very efficient. During the compile time, this kind of stuff happens. Yes?
Third f function, no parameters.
Where is the third f function?
Possibly.
Yeah, okay, you mean there is a function f with no parameters.
No parameters. Compatible match, exactly double or?
Of course double, because the third one doesn't take any parameters. It is a completely different signature. Good. How about this? I have three f functions. One takes integer double, double integer, integer integer. When I call it this way, the exact match calls this one, right? Two integers and two integers. When I call it this way, 5.3 and 4, double and integers. How about this? Two doubles. There is no exact match. If I promote this to a double, okay, if I promote this to a double, or if I demote this to a double, then I can make an integer out of it. Then this one is a double. Then I can call it, but I can do the same thing with this one too, right? I don't know which one to call, 1 or 2. Or if I demote both of them, the third one, okay? So compiler will not give you any error messages for these three function definitions. They are all different functions with different signatures. Compiler is fine with this one. Compiler is fine with this one. But for that line, compiler is going to say, I am confused. There is an ambiguous call, okay? Ambiguous call. This may mean three different things, but in standard programming languages, things should mean only one thing, okay? So it's going to give you an error message and it will not continue. Okay? It will not continue. Good. There is a way of forcing the compiler to use one of the overloads of it, and you can do it this way. I am calling f with those parameters, and I want you to use integer double overload. Okay? You are resolving the function call, and you are telling the compiler that this is the function to call, an integer double. Okay? This one. Well, I mean, overloading doesn't make much sense in this case because you are telling the compiler which one to call, but if you like to do it, you can do it. Okay? Good. Any questions so far? If there are no questions, I will take some break. After the break, we will continue with our discussion. Kaç kişi imzalayamamışlar arkadaşlar?
Ben hocam kağıt.
Kaç kişi imzalayamamışlar arkadaşlar? Size ikinci derste imza atayım, tamam mı? İkinci derste de aynısı olacak.
Hocam Teams'e gelmedi, onu mu diyorsun?
Ne gelmedi? Teams'e geldi her bir şey.
Geldi sekmelerden bakalım.
Bana gelmedi de ben anlamadım.
Sana ne gelecek ki? Bana da bir şey
Normalde
geldi.
arkadaşa şu more kısmında attendance sheet olarak
Sen Teams'e gitsene.
Tamam.
Aç bizim grubu. Tamam bak orada.
Bu dünkü hocam.
Tamam dünkü zaten hep aynı işini dolduracaksın. Hep aynısını dolduracaksın.
Wali list yapısına sahip bir şeyle overload yapabilir miyiz? Wali list gibi bir şeyle overload yapabilir miyiz?
Neyi?
Yani wali list diye bir şey var ya 3 noktayla tanımladığımız bir.
He.
Onunla overload yapabilir miyim? Çünkü o zaman,
Ya yaparsın da o tür şeyleri C++ çok sevmiyor.
çünkü o çok o zaman karmaşıklaştırmıyor bir şey.
Çok ne?
Karmaşıklaştırmıyor mu?
Evet yani onu yaparsan zaten her bir şey oluyor. Yani olabilir. Yaparsın. Compiled olur. Çalıştırdığın anda problem çıkacaktır orada. Yani çalıştırdığın değil de çağırdığın anda.
Şu tarafından girdim de onu sanmak üzere.
O sakat, onu İlhan'a söyleyin düzeltin.
Hocam benimkini de düzeltebilir miyiz? Ben yapamadım da onu bilmediğim.
Neyi düzelteceğini ben anlamadım.
Yani bugün şimdi yok yazıldım ya ben yapamadığım için.
Tamam yapsaydın. 2 gündür bas bağırıyoruz burada ya. Öğren.
Bu yuvarlama işi falan
Kağıda imzala. Birazdan kağıt vereceğim, imzalayamayanlar kağıdı yapsın diye.
bu hani type checking hep
Ya
oluyor mu?
anlamıyorum. Birisi yoklama soruyor, birisi C++ soruyor, birisi...
Sonra sorayım istersen.
Sor.
Yani bu şimdi mesela hep check ediyor ya mesela integer, double falan uygunluğuna
Ha,
bakıyor.
evet, promote etmeye çalışıyor.
Ben onu iptal edebiliyor muyum mesela? Ben direkt doğru şey girsin istiyorum mesela.
Yok, o C++...
Compiler ellemesin yani ne girdiğini. Debug etmek için falan görmek istiyorum belki.
Belki warning verdirebilirsin C++'a. Yani eğer promotion, demotion yapıyorsan bana ver, hata ver diyebilirsin ama hata değil de warning. Ama compiler'a dilde olmayan bir şeye hata verdiremezsin. Doğru değil o. Çünkü standart olmayan bir şey yapmaya çalışıyor. Warning olabilir.
Hocam yoklamayla ilgili sorunlarınız ders çıkışı. Hocam sonuna doğru
Şimdi kağıt vereceğim, kağıda imzala.
ya işte 2 kere hocam imza atmış olabilirim emin olun. Bir daha
Orada ismini gördün mü? Ben yaptım ya orada. Gördün mü?
bakmaya çalıştım hocam ama sonrasında
İlan şampiyonlar bir sistem yok. İkisi de kendinin hesabından gittiği sürece problem. Başkasından gelirse
Sadece diğer mi oynayacağız? Abi yani 32 takım olursa yaparız. Abi grup yaparız. Herkes en az 3 el oynamış olur. 4 olur. Ama mesela 64 olursa birden fazla olmaz yani. Belli bir en arka boş olabilir. Gelirim yanına. Delikanlı adam var ya, her şeyi... Ama astigmat alıyor ben bunu yapmıyorum.
Hemen aynı şeyi görüyorum.
Sürekli böyle sıfır dolayısıyla normal sayı.
KVP izledim hocam.
Yap hocam.
Göster bakalım.
Niye böyle aldın mı? Bir şeyler şey yapıyor adamlar bunu Arapça anlatıyor. Diyecek başka bir kafa yetişmiyor. Klasik Arapça, modern Arapça. Onu acaba ikinci mi yazıyor? Kolay ben 430 space yaptım. Bir saniye dur çıkmayın. Ne zaman? Buradan mı? Kapşonu çıkarmamış. Okey, Emre atıyorum. Attım kartı ekrana. Kocaman şey dersin.
Siz saçıyorum oğlum, ben mecbur yapıyorum. Sigara içiyorum.
Abi ben onu riske giremem. Ben çünkü randevu aldım.
Okay. Um, as always, these kind of stuff are for your convenience. I mean, I can live my life without overloading, and we have been doing it in C without needing much overloading. Overloading is supposed to make your life easier, but if you use it in the wrong way, it gets confusing. Instead of being helpful, it gives you more trouble. So be careful about it. Avoid these kind of confusing overloads. That's what the book says. Automatic type conversion is always helpful when we say, okay, remember the math library functions, they all take doubles, but we are okay to send integers or floats or short integers or long integers to that library. It is not because square root is overloaded with all these kind of types. It is because there is an automatic type conversion going on. Well, I told you that previously. Instead of sending a integer 90 to the square root, send 90.0 before. I keep saying the same thing. It is true. But if you send an integer, the automatic type conversion will automatically make a new double for you that is equal to 90, and will send it there. You need to know about what kind of conversions are possible and what kind are not possible. Okay, integers are automatically converted to doubles if needed. Floats are converted. Characters are not converted, so you cannot take the square root of a character A. You might say that, well, A is 65. Why don't I take the square root of 65.0? It doesn't do that. Okay. I think I talked about enough on this. That's why I'm going to move on. A new topic, default arguments, which is simple, but we use it a lot often. And it's like overloading. It is not overloading actually. It is something convenient. We use it all the time. Default arguments. So in C++, they say that it is possible to declare your function like this. Show volume says that I will have three parameters, length and width and height. Well, it's a simple volume calculation function, okay? It's going to multiply length and width and height together, and it's going to calculate the volume of a rectangular prism, okay? That's what it's going to do. But you see these default arguments here, equal sign 1, equal sign 1. It means this. If somebody calls this show volume function by this 2, 4, and 9, of course this is called by a value, copy 2 to length, copy 4 to width, and copy 6 to height. This is all fine. This is what we have been doing. But if somebody calls this show volume with just 2 parameters, you are going to copy 3 to length, 5 to width, and 5 to width, and since there is no third argument passed, I am going to take that argument as 1. Okay, so it is going to be the same as 3, 5, 1. Okay, so I am taking, if the argument is missing, I am getting the default argument from the argument list. Okay, and if somebody calls it with a single parameter, okay, single argument, this is my first argument, the second one and third one is missing, so what am I going to do? I will take them as 1. So this one will show on the screen, what, 8 times 6, 48. This one will show 48 on the screen, multiplication of these three numbers. This one will show 3 times 5 times 1, 15. And this one will show 7 times 1 times 1, 7 on the screen. Okay, so this height is defaulted to 1, width and height defaulted to 1. Okay, so this is like just a minute. This is like you overloaded this show volume 3 times. One will take 1 parameter, the other one will take 2 parameters, the other one will take 3 parameters. In fact, there are no 3 overload, just a single function definition with a single signature, but last 2 parameters, last 2 arguments are overloaded. This is called default arguments, and in C++, we use this very, very often. Yes?
If there is another overloaded show volume function and that contains just 1 integer as a parameter.
Well, what would you do as a human being? You would get confused, right? Which one am I going to call? So it's a compiler error. Okay? It's a compiler error. The question is, since nobody is asking their question with a loud voice, I have to repeat it again. The question is nice. What happens if I overload the show volume with a single integer, okay? Well, in that case, it would get confused between this one and this one, right? So it is going to give you, when you make a function call like this, okay, the function definition is not a problem. You can define it. But if you call it with a single parameter, then the compiler says that, I don't know which function you want to call. It is ambiguous. And we don't like ambiguity in programming languages. Yes?
In the second show volume, why height is equal to
That's the rule, okay? If the number of arguments is not the same as the number of parameters, you start from the last argument, the last default argument. You start from the last default argument to use. So the question is, 3 is length, I understand that, but how do you know that 5 is not width or height? Okay, that's the rule, okay? You do this. Where is my pen? This is the first one, second one, and the third one. I know this from C, right? From the C language. And in C++, this is for this one, and the second one is this. Third one is missing, so I am getting this one. By the way, you cannot write a function like this, show values, integer I defaulted to 1, integer k. You can't do that, okay? This is not possible. If you are going to give default arguments to a function, you should start from the right, from the end, okay? So without giving a default to the last one, you cannot give a default to the first one. This is not possible. You have to start from the last one. So if you are going to provide a single default argument, it has to be height. If you are going to provide two, it has to be width and height. If you like to provide three of them, okay, then you can put three of them in there. Yes? You don't understand this one? Well, it is simple. This compiler will give you an error message. You can't do that. If you like to give a default argument to this function, it has to be this integer k1. This is okay, and this is okay. Integer I1, integer k1. These two are okay, but this one is not. Why? Well, that's the rule. I mean, it is kind of logical, right? I mean, when you say call SV1, okay, the logical thing is that this is the parameter, okay, this is the argument for the first parameter, okay, this one, and this one. If I do this and if I copy it to this I, then k will not have any values, so that will be a compiler error. It gets confusing, so they choose it this way, okay? So the compiler immediately, when you make a call, it immediately starts following this rule. The first argument will go to first parameter, second to second, third to third, right? That's the rule it follows. If I can do this kind of a stuff, that rule kind of is violated, and that's not good. Maybe if they tried hard, they could have found something to make this possible, but no, I mean, and the way we use functions are like this, okay? Sometimes there is a function f1 with 10 parameters, okay? With 10 parameters. The first one is an integer, I, okay, comma. The second one is another integer. The third one is a string. The fourth one is something, something, something. Okay, the last one is a double D. You start from the beginning and you say that always place your least critical parameters to the last. The first one is the most critical, and it is the one that you play with most, okay? The first one is the most important one. The last one usually is not changed, it stays the same. Okay, it's a parameter, but it stays the same. So we don't pass them most of the time. Although this f1 function, it's a complicated function to use. It needs 10 parameters. But if most of the parameters are overloaded, most of the time I call it with just 2, like a simple one. Okay? So that's the rule. Try to place your not frequently changing parameters as your last parameter so that they can be defaulted. Yes?
Can we assign a variable as a default parameter?
This is not assignment. Okay? This is argument specification. This is not assignment. You are saying that, can I put a variable in here, right? Not variable, but maybe a named constant. Named constant. Okay? Because this is a function definition, right? Where are you going to get the variable for this function definition? A global variable? Well, I mean, if you do that, that would be very confusing, very difficult to understand that code. You mean that when you are calling it, you are going to make your defaults that numbers? No, that's not a good idea. And the second thing is that these default arguments are resolved at the compilation time. When you compile your code, it is already decided, okay? During the runtime, your runtime code doesn't know about those default arguments. Compiler already, their names are not default parameters, it is default arguments. If you don't provide the second and third argument, by default their values are 1. That's the meaning, okay? If you don't provide the second and third argument, by default their values are 1. So the compiler produces a code that calls this show volume with 3 parameters. The first one comes from here, the second and third will come from the default argument list. Yes?
I don't think it is this smart, but can we assign another function to the argument?
Another function?
Yeah, like call a function in the parameter.
Well, how are you going to do that during the compilation time? Are you going to call that function and get the result? And again, this is resolved during not during the runtime, during compilation time. Okay? So the answer is no. Okay, let me show you this simple program. Okay, so why don't I turn the annotations off? Yeah. Okay. Show volume, we define it this way: length and width and height. Okay, 2 default arguments, and I can call it this way. Okay, so this will print 4 on the screen, 4 times 1 by 1. This will print 24, and this will print, I guess, 48. Okay, and the line 15 starts the implementation of the show volume. See, I don't list the default arguments in the implementation, only in the header, header file, or the definition of the function header, you provide these default arguments. Okay, so this is kind of a clue that the compiler doesn't need to know the implementation of the function to compile these 3 lines of code. It is enough to see this line, because compiler says that here I am going to call this show volume with parameters, okay, 411. Okay, it doesn't need to see the implementation of it, because this line is enough for the compiler to make that call. The implementation, okay, doesn't know about the arguments. The implementation of the function doesn't know about the arguments. The implementation will think that I will need 3 integers, and somebody is going to give me these 3 integers, and I will run. The implementation doesn't know that its arguments are, its parameters are defaulted, because whenever you send the arguments, they are defaulted. So implementation says that I will get 3 integers, okay, and I will print them on the screen 1 by 1, and I will multiply them and print it on the screen, show volume. Okay. I think somebody asked this question: what happens if I have a show volume function, okay, that takes a single integer I, okay? The answer is, yeah, your program will compile, and it will be fine for this line and for this line, but for line 12, your compiler will not know it should call this one or it should call this one. So line 12 will be a compilation error if I do this. Okay, good. So this is the final output of it. Any questions about the defaults? Yeah.
Can we send something like null compile that to show that we are using default argument function? Türkçe sorabilir miyim?
No. So What do you mean? Instead of one type null here?
Instead of, we can just use for null to show that we are using the default argument form.
Why? This is already doing that. This is already doing that, right? I mean, why do you have to type null?
You said that the compilation error will occur if we.
Well, maybe, I mean, if you like to prevent such a compiler error, you could say, well, show volume 411, you would said, right? You know the default value. Or you can say, show volume integer, integer, and integer, then 4. This will resolve it. Okay? I am, this is kind of overloading, right? I am using this one that takes 3 integers. This is overloaded. One of them will take 3 integers, the other one will take 1 integer, right? You are saying that I am calling the overload that takes 3 integers, and you provide the first one, the second and third one will be the default arguments. You could, but again, not that much meaningful. I mean, it is not much meaningful to have these two lines together, and this makes it even much more not meaningful. But that kind of thinking line is good, to try to understand what's going on, try to understand, can I force the compiler do this and that, is something that you should do all the time. Okay, is the attendance done? Did you guys? Where is my? Okay, here it is. So this GTU editr doesn't work. So where do you report errors? Where do you report these kind of problems? To secretary? If you see something doesn't work, what do you do? You don't do anything? Send an email to someone, okay? Tell it to the secretary, okay? Tell her that the G2 editr wireless doesn't work at Z23. If you don't tell it to anybody, who is going to fix it? It will get fixed by itself. Okay. Well, nobody. I understand what's going on, because I need to go to the second one, not the third one. But I don't have the link for that one, so maybe I should get it from Ilhan. We are going to check it later. So how many people didn't sign their names using this online form? How many people? How many people did not sign? Did not sign. You did not sign it. What else? Okay. So you see me after the class, okay? You are going to sign my attendance sheet. Okay, good. Let's move on. Now we are going to talk about testing and debugging functions. Okay. How do you debug your functions in C? Okay. This is what usually people do. They put lots of printfs everywhere, right? Lots of printfs. And that's a good idea. Beginning of the function to see if the parameters are received okay. End of the function to see if I am returning something correct. After I do the scanf, before the printf and etc. Sometimes you do stuff, it's a good idea to print it after the scanf or cin, right? To see if I am reading the things right. And most of the time you realize that you didn't read it right. You didn't put the ampersand sign in the scanf by doing this, right? Okay. So printfs are nice, but the thing is that after your program is compiled and running nice, you have to remove all those printfs out, right? You have to delete them one by one. The bad thing is, after you delete all those printfs, you realize that there is another error, and you put those printfs back, and sometimes you forgot to put the right place, and so that becomes a pain. Okay, so to solve this problem, this is what we do with the lots of cout statements. Okay, let's say I like to write a function that takes an integer and a string. Okay, and at the end of this function I like to return a double. So this is what I do. Print the integer and the string immediately before, just after the function starts, and before I return d, I print this d out. Okay. But as you see, I put these funny preprocessor directives around these print out statements. I say if no debug flag is not defined, then print it out. If no debug flag is not defined, then print this out. Okay, what is the meaning of it? The meaning is this. Okay, do this only if no debug flag is not defined. If somebody defines no debug at the beginning of the program, if that person says, okay, if that person says, where is it, let me show you that one. Yeah, if that person in that program says that define no debug, okay, the preprocessor will automatically take all these lines out, and they will not be compiled. So that's a very nice feature actually, and we use this a lot. So for the purposes of debugging, if you have lots of printout statements, okay, if you have lots of printout statements for the purpose of debugging, surround them with these two simple lines. Okay, that way you are telling the preprocessor that these are only for debugging, and if no debug flag is defined, don't compile this. You know the conditional compilation, right? Define something, and you know multiple header files. Do you know those? You don't? You don't? If not defined, then define this, etc. Header files. You don't know about the header file. Inside the header file, beginning of the header file, if not defined my header, then define my header, and this is your header, and etc. And if you didn't say this,
We have used it, but
what?
we have used it, but I don't think anyone researched what it was.
How you just directly, okay, that's the meaning. Okay, so you know this rule, right? These are for the preprocessor directives. If something starts with the sharp sign, it is not for the compiler, but it's for the preprocessor. That's why before the include preprocessor directive, I have the sharp sign. Okay, you are telling something to the preprocessor. You are telling the preprocessor that if nobody defined my header, okay, I am going to define it, and I am going to this and this and this. That's what you are saying. In this case, I am saying that if nobody defined this no debug flag, then compile this. Okay, end of. And the same thing here. If nobody defined this no debug flag, then compile this. If somebody defines it at the beginning of the file, like, okay, where is it? Okay, if somebody like the one that I showed you, okay, if somebody defines this at the beginning of the file, define no debug, the preprocessor will say that, okay, I am not going to compile this line and this line, right? Those are just simply will be ignored. When they are ignored, then you are not going to see all those debugging information on the screen. So when you realize that there is another error with your program, you just erase the first line, and your printouts will be available again. Okay? So that's a nice way of dealing with this kind of stuff. Even nicer is, you don't have to modify your program by adding that no debug flag at the beginning, okay? You compile your code with this -d no debug flag, okay? G++ -d no debug, it means that compile this file with no debug flag defined without modifying your program, okay? Or you tell the compiler that I am going to compile this program in an optimized form, -03. -03 optimizes your program, and by default it defines this no debug flag, okay? In that case, your code is optimized and all the debugging related printouts, they go away, okay? This is how we deal with the loss of cout statements issue. Okay, that's one thing that we do all the time. So I encourage you to use lots of cout statements to print out what's going on with your program internally. Of course, your final customer doesn't, they don't care about what you are printing for the debugging. In fact, they are annoyed by it. So you need to turn off all those debugging stuff from your code. But to turn them off doesn't mean that erase them altogether, because you may need them later for further debugging. So turn them off. You just define this no debug flag. Okay, try it and it works very nice. Another way of debugging your programs is compiler debugger. Okay, how many people use the standard debuggers, either Visual Studio or the GNU debuggers? How many people? 1, 2, 3, 4, 5, 6, 7. Okay, try to learn how the debuggers work. They are very nice. Debugger is basically a simulation environment. Okay, it takes your program in, and you say that, okay, run this line, now run this line, now run this line. You run your program line by line. While you are running it one by one, you say that what is the value of this variable? Okay, you can ask it and it will show you. Okay, or you can say, what is the value of this memory location? Give me the contents of this array. Or you can say sophisticated stuff like, run this program until this variable becomes 7, so that you can run your loop until that variable becomes the value that you want. Okay, so use your debuggers effectively. That will help you. That will help you understand what your program does. Okay, it is, I mean, most of the time when you debug your program that way, when you expect that your control should go into the if statement, but it doesn't, then you understand that you are making a mistake with your if condition or while condition, etc. Well, I mean, C language doesn't define a debugger, but for the G++, yeah, we have GNU debuggers, GDB, XGDB, and for, okay, this, do I have GDB? GDB is a primitive debugger. GDB, do I have it? Yeah, well, I didn't install it, but you can install it. It's a command line based debugger. So you say next line, and next line. But there are very nice graphical interfaces to the GDB, like XGDB. It has a graphical user interfaces. Or you could use visual debuggers that are available. Like, what compilers are you using in Windows other than G++? What? Visual Studio? Yeah, Visual Studio comes with its own debugger. There is a debugger available. So I think under the debug menu, there is a debug menu, I guess. Okay. Under the debug menu, you will say start debugging. By the way, to debug a program, you should not compile it with any optimization flags, because optimization flags, they take all the flagging, debugging information out of your program, and it will be optimized. So you should compile it with the -G options, I guess. -G means that leave debugging information inside my executable so that I can debug it using a debugger. Okay? So maybe I will ask Ilhan to give you a session about, in one of our problem sessions, about the debuggers, or just you find your debugger yourself. Another way of this is related to the first one. Putting the debugging statements in your code is this assert macro, and we are going to do it in a few minutes. Okay, this is the assert macro. Assert macro does this. It's very simple. It's a macro. What is macro? Macro is not a function. It's kind of, what's a macro? It's what? Combination of stuff, but what kind of stuff? Macro is like a function, but it's not a function. It is only for the okay, it is handled by the preprocessor, not by the compiler. Okay? So assert is a macro, and in assert statement, you do this kind of stuff. Okay? A function, okay, a function, blue, a function that takes an integer I. Before that function starts running, I call this assert macro. I say that for this function to work, I should be greater than or equal to 0. That's why assumption is, for example, f is a factorial. Okay, let's say f is my factorial function. If somebody calls f with a negative number, okay, that's a bad thing. And in my documentation, I told everybody that you should call this f with a non-negative function, non-negative value, integer, and everybody knows it, but yet somebody can call it with a negative number by mistake or on purpose, and etc., whatever. So by putting this assert at the beginning of this function, I am making sure that I is always greater than or equal to 0, okay? If it is not, this program will be terminated. Okay, assert macro says that at line 250, there is an assertion fault, and I am going to terminate this program. Okay, this is done automatically. So whenever I run this line, whenever I execute this line, this check happens. If that check is valid, if I is greater than or equal to 0, my program continues. Otherwise, my program will be terminated. So it's kind of a safe check. It's kind of a debugging stuff. So this should not happen, actually. I don't like this to happen, especially if this happens in my customer's hand. That's kind of embarrassing, right? I mean, it says there is an assertion happened, I is greater than or equal to 0 at line something something. Your customer should never see such a statement from on your screen, right? If your program is going to crash, it should crash appropriately, not this way, okay? So it is for me only, for debugging purposes. If I see this crash, I will start debugging my program to see why anybody is calling this function with a negative number. And when I find it, I will eliminate that case. Asserts are good for that purpose. Okay? Yes?
So there is no difference between if statement or
okay. I was going to ask you the exact same question. So ask the question again.
There is no difference between if statement.
Yeah. What is the difference between this one? How about this? If I is less than 0, exit -1. How about this? What is the difference between this one and this one? Okay, that's a good question. And back to you. What did I say? Assert is a macro. It's not a function. What is macro? Macros are handled by the preprocessor. Okay. Well, maybe you can guess it. The thing is this. If you define the no debug flag, asserts are gone. Okay. If you compile your program with no debug flag defined, compiler doesn't see this assert line. Okay, it goes away. So your preprocessor knows that this statement is only for debugging purposes. Okay. Your preprocessor doesn't know that this is for debugging purposes, right? It looks like regular statement. So either you are going to come back in and you are going to remove these lines yourself later, or you are going to use assert statement, okay? Assert statement, assert macro to define it. And while you are debugging your program, asserts are alive. They will help you. Once you are satisfied and once you see that there is no error in your program, everything runs fine, then you need to remove these asserts, right? You don't remove them by deleting them. You just compile your program with this flag minus the no debug. Yeah.
So this line works in a preprocessor type.
Yeah, well, it works at the, well, preprocessor takes this and it produces a C code that will make this check and terminate the program if it is not valid, if no debug flag is not defined. If it is defined, then preprocessor just ignore this one.
So this C code that runs in a runtime.
This part is C code, yeah. Yeah, that runs in the, if no debug flag is not defined, okay, if it is not defined, then debugging is on. Your preprocessor produces code that will run all the time. That's bad for the performance, right? You don't want to check if everything is fine. You don't want to check if I is greater than or equal to 0 all the time. That's a bad thing for the CPU usage, right? So for your final release, for the release that you are going to send your paying customer, you don't want to send this line, okay? Why? Because it's bad for the performance of your program. So what you do is you just remove it. How do you remove it? You don't remove it by deleting it. You remove it by defining this no debug flag, or maybe optimize your code by the -03 or whatever the flag you have for your compiler. Okay, so that's the nice thing about this assert. We are using the nice capabilities of C preprocessor mechanism, which was invented in 1974-75 before Unix. Yeah, okay. To be able to use assert, you need to include this header file, C assert. Remember, assert comes from C language, and to include the C headers, you need to put a C at the beginning. Okay. Macros used similarly as functions. Try to learn about macros. Maybe they didn't tell you about macros. Maybe I'm going to write a few macros for you. But maybe you don't remember anything like this. Define, take the square of x as like x times, like this is like a regular define, x times x. Okay, if you make such a define, it's called a macro now. Okay, you could say in your program, cout square of 5. So your preprocessor, whenever it sees such a string, it will replace it with 5 times 5. Remember, define size 24, etc. Whenever it sees a size, it replaces it with 24. It is the same thing, so it is a little bit more complicated. When you do it this way, if it sees this, it will replace it with x times x, and x is 5, so it's going to be replaced with, okay, instead of seeing this, compiler will see cout 5 times 5. Okay, but there are tricks on it. If you call it with 3 plus 1, compiler will replace this 2 plus 1 like this. X becomes 2 plus 1. It's going to be 2 plus 1 times 2 plus 1. No, well, you didn't tell the compiler to use the precursor to use the parentheses. That's why people usually define it like this. Okay, and this too. So it will be like this. So now this is fine. So these are macros, and assert is a macro like this. So try to write assert macro yourself. Assert macro is very, very simple. You can write it yourself. Okay. So excerpt macro example is here. If compute coin is a function that will take coin value, number, and amount left, and I am saying that if you are going to call this function, okay, your coin value it should be between 0 and 100. Your amount left should be 0 and 100. Okay. Now I am checking it. Current coin should be greater than 0, less than 100. Current amount left should be greater than or equal to 0 and less than 100. If these conditions are not met, then terminate my program. Before I end today's lecture, I always ask people this. Since assert is a nice thing, we try to use it all the time. Okay. How about this? Can I write this code? Of course you can. Okay. And I am doing this. Okay, I'm incrementing I by 1 and checking if it is greater than 0. It's a C code and it can run, right? No problems. So there is a big problem with this code, very, very big problem. And it's not going to cause any compiler errors, and it will give you very big trouble in terms of your customer complaints. Your customers will say, yeah. What do you mean? Just explain it a little bit.
It increments, changes the value of I.
So yeah, well, if I want to change it, I mean, if the statement after this one is like this, okay, instead of doing this, I am just saying that, okay, just get rid of this one, and I'm putting this plus I in there. I am optimizing it. See, I'm smart.
But when I'm compiling the code, I don't want the customer to have that line. I'm compiling their product, so it won't do what I want.
Yeah, you understand the problem? If I do this kind of stuff in an assert statement, when I optimize my code with the -d no flag code, okay, this line will go away, remember? If this line goes away, my customer is going to receive a f function that doesn't increment I. But when I debug this function, my I will be incremented. Those are two different programs in terms of what they're doing, right? So inside an assert, don't do this kind of modification stuff, okay? Don't modify anything. Just read values and make sure the values are right. Okay? As I said, C programming, C++ programming has lots of details. That's why the language is very powerful. Powerful doesn't come with cheapness. You have to be very careful. You have to experience lots of errors. Once you realize them, once you find them, once you understand them, you become a better computer engineer or scientist than the Java people or Python people. Okay? Good. Okay, that's it for today. I will see you on Monday. Şu kağıtları imzalamayanlar gelsinler buraya, şeyleri. Zor değilse sor. Zor değilse sor.
Yok hocam.